and any discussion. Good morning. Welcome to Object in Description, the presentation of the new version 1.4 with many new functionalities compared to the earlier one. First of all, what is Object in Description? It is a standard project of MPAI, Moving Picture Audio and Data Coding by Artificial Intelligence, international, unaffiliated, not-for-profit association based in Geneva. We develop a standard for AI data coding. We have a rigorous development process that I will spare today, but also attaching clear IP rights licensing frameworks. That are the main features of our standard. So we are, today, we are presenting first object and scene description. It specifies data types and associated qualifiers. This is a word that you will hear more and some explanation in a few seconds. These data types and associated qualifiers are used to specify unimodal and multimodal objects and scenes in virtual environments having a space-time attributes. Then we also specify the AI modules and the data types, words that will become also clear in a moment. And finally, the television media analysis AI workflow. So it's a workflow where you put a television program and you get at the output the description of the scenes, what people say, who they are, and so on and so on. So the first element is the AI framework. The AI framework is an MPAI technical specification. It specifies the architecture, the interfaces, the protocols, and the APIs of the AI framework, which is especially designed to execute AI-based implementation, but also suitable for mixed AI and traditional data processing workflow. So we are kind of agnostic to the technology that are used inside the AI framework. So this is a simple reference diagram. You will see that we have a user agent, we have a controller, we have APIs for the AI modules. The AI modules are the basic processing elements. They are combined and become AI workflows. And below we have a number of functionalities that we can access, in particular for security. So this is the television media analysis workflow, AI workflow. So, as I said, imagine that you have a television program in the MPAI language. This is an audiovisual object. And you see that, first of all, the video is split into video and audio. And the two have separate but interacting story. First, the video, we want to detect when there's a visual change, and for audio, when we can segment the audio in audio that has different features. So, taking the visual change detection, the output is image and time. We'll see more exactly what, and this is passed to something that is called Face ID recognition. It is an AI module. And for audio segmentation, we get the speech, the speaker time, and any overlap information. And then we have the automatic speech recognition, which is fed with speaker time, speech, and overlap information. And then we have the audiovisual alignment, which is a critical element, AI module, because it has to combine the faces with the speeches. The output is a set of data that are used to describe the audiovisual scene. The audiovisual scene, we'll say more about this, is a snapshot because we are only dealing with the description of the video when there is a significant change in audio or visual. The combination of all these descriptors, actually, is called an audiovisual event descriptors. This, as you see, is the output of the system. So, what does the standard specify in terms of AI modules? So we said that there is an AI workflow. That was a brief introduction. I cannot say more today. So now we talk about modules. The modules are provided as building blocks for to implement the AI workflow of television media analysis, but also quite a few modules that are used by other standards, in particular, connected autonomous vehicle, human and machine communication, multimodal conversation, portable avatar format, and a very interesting standard that is being developed that is called XR venue, live theatrical performance. So this is it's a rather impressive list of AI modules. I just wanted to show you something. Let me take one this. So this is to say that all workflows, all AIMs and all data types have an individual page. This is the page for the module that is called Visual Direction Identification. It says that it identifies the point of view signaled by the index finger of a human body in a space described by this visual scene geometry. So this is what we have. So this is the simple diagram as a single AIM, but the AIM is actually split in more. So this is something. Let me close this and go back to here. Let me go into more visual presentation of what we have. So we have the visual change detection. So it receives a video as input, and it provides the times at which a significant change in the video scene has been detected. And then it also gives the first image of the changed video. So that's what the visual change detector AIM is supposed to do. We have another one, the one that I would say was very important. Indeed, it is very important because it provides the descriptors of the audiovisual scenes whose audio or speech objects and 3D model objects or visual objects have compatible identifiers if they have the same position. So essentially, this box takes in these types of scene descriptors and combines the audio and the visual object that are at the same position and gives them a compatible identifier. I say compatible and not exactly which identifier because MPAI is not in the business of deciding what is the type of identifiers that the application will use. So very few words to describe the reference software. The reference software is described for the audiovisual alignment AI module, but actually you have a complete implementation of the AI workflow. That's available as open source at the MPAI website. And so here we're just saying that it's released with BSD 3 closed license. This software shows a working implementation of the workflow. We don't say that it can be used for anything else. And as a warning that there may be components they are all open source, by the way, that you must accept in order to use this software. So this is a guide to the code. I will skip this. And this is the acknowledgement to the people that have developed, and they are the people in the AI Framework Development Committee. They are those who have developed all this software. Some words about conformance testing. So it's important to have an AI module working. That's certainly an asset, but you have to know if this AI module conforms with the specification. And what we say is that so it is conforming if it receives the speech scene descriptors, and the speech descriptor validate against the speech scene descriptors JSON schema. That is what we say, and pretty much the same happens for the other data types. MPAI, this will be part of a bigger talk about the MPAI mission. No longer provide the reference software, the conformance testing, but also the performance assessment. Performance assessment is, we do not say how you assess how good an AI module is. We say how a performance assessment report should be produced in order to have something that is compatible, because you may decide to assess the performance using a certain data set or certain conditions, and all that has to be specified in the report. So here you will see that you have to give the identifiers, the data types, and how the performance should be expressed. And here we say that the performance is given by three numbers. The number of times the AIM correctly identifies the objects that are aligned, incorrectly identify the object that the data set declares are aligned, but they are decided as actually they are not, and when they were aligned, but were declared as not aligned. So this is an example of how performance assessment is specified in terms of how the report should be provided. More about data types. So we have already seen data types coming in and out, and the important role that they play. So all data types that are used in an MPAI AI module or workflow are specified. Most data types are provided by the OSD standard, but there are quite a few that come from other. So let's classify the data types provided by OSD, MPAI OSD. Objects, you will see that there are quite a few objects. Then the geometry of a scene, and this is the geometry, the spatial temporal arrangement of objects in the scene. The descriptors, which is the geometry plus the objects. The event descriptor, this is a series of descriptors. I said the descriptors and the geometry are snapshots. When you combine and you get the full description in time, and then there are a number of other data types, and I will introduce some of them. So let's go to something that is basic. It's quite basic, and in the sense that we are defining an object, but we are also defining basic objects, and there are different roles. So a basic object is a data type that includes the data of a specific media type that is perceptible by a specific device and or a human. So that's the definition of a generic basic object. Then we have descriptive data regarding the subtypes, the formats, and attributes of the data, which is what I have called qualifiers. You will hear more about this. Then we say that the basic object may include the ID of the virtual space where it is located, the ID of the basic object itself, and then we have the IDs and also the space-time information of any parent object and child object, the space-time information of the basic object itself, the qualifier of the specific data type, and the right can be exercised on the basic object. If you wonder why we need this, well, it's because this afternoon we will introduce another standard, which is at version 2.1, which is the MPAI metaverse model. And well, the metaverse that the MMM specifies assumes that you can move, you can do things. By you, I mean a process that represents you. You can do things in the metaverse, but only if you have rights. So here you have an object, and in that object it is written what you can do or you cannot do. And then also a set of annotations. So more about the notion of basic object and object. So a data type can have different formats. So if you take audio, you can have MP3, you can have AAC, you can have audio in PCM samples, you can have ambisonics, you can have a lot of a way of expressing. It's always audio, but it's represented in different ways. Qualifiers is a special type of metadata that provides additional information about the data, because if you want to process that instance of audio data, you need to know if it is MP3, if it is AIC, if it is anything else. And an object is the combination of data qualifiers. So when you see the word object used here, we mean that you have the data, but also information about what the data is. A basic visual object is visual data having only one qualifier, but also space-time information. Then an object can be combined in a scene, and in that case, the space-time information of the object can be overridden by the scene. And the visual object is a combination of basic visual object and visual object typically in a hierarchical fashion. So here we have the object now. It includes a collection of basic object and object, possible with a hierarchical structures where you have an object that may contain basic object and other object inside. An object may include the idea of a virtual space where it is located, the idea of the object, the space-time information of the object, the basic object and the object included in the object, the annotation and the rights. So the structure is similar, but it has some differences. So here are the different types of media object that we specify. We have the generic object, as I said, but then we have 3D model, audio, audiovisual, LiDAR, offline map. This is something that is used in another MPAI standard, which is called the Connected Autonomous Vehicle. Radar, speech, text, ultrasound, and visual. So these are the 10 media object types that we specify. So here we go more into detail. Some things will be repeated, but here we take the basic 3D model object. So what is this? So it contains the idea of a virtual space, the idea of the object itself, the qualifier, the data qualifier, the space-time information, the rights that can be exercised on this object, the set of annotation, and for the annotation we give the space-time information about the annotation. You may very well not have just one, and also the right that you can have to work, edit, change the annotations. Then you have information on parent object, information on child object, and then we have a set of attributes that are specific of basic 3D model, but also visual model. They could also be made to apply to LiDAR, but at the moment this is not done. So we have the mass of the object, the material property. So is it material or is it immaterial? So you can see it, but you may want to be that you can compenetrate to object having immaterial property. The property to be subject to gravity, the texture map, and the audio characteristic of the object. Set of annotation and the right that can be exercised. So this is the typical way we represent the syntax of this data. So we have the header, we have the M instant, the scene descriptors ID, the value of gravity, because here we have a scene, 3D model scene description. So a scene is a combination of objects. Here we are saying that they are of the same media type. In a scene, you can decide the value of the gravity. I mean, this may not be needed in other application, but in the metaverse, this is needed. Then we count how many objects there are, and then we say how many scenes there are in the 3D model scene. This is again the same representation. And now we go to the last type of OSD data types. So here we have the annotation that I have talked about. Audio source, you will see something. Bounding box, this is useful because we use this, for instance, in the connected autonomous vehicles. Coordinate, devices in geometry. So you can have different devices capturing media, and they have a geometry, and you may need to describe. This is something that is used in a standard being developed called audio 6 degree of freedom. Instance identifier, so you want to give an identifier to anything. Light source, I will say a few words. The audio object characteristic also. Orientation, that is very clear. Path, perceptible entity. Well, this is anything that can be perceptible. So that can be percepted. Then we have the point of view, the position. Right parallel pipette is used to describe a space. So you want to define the space. There are many ways. They are. But the simple one that we use is the right parallel pipette. Others are possible. Selector, simple location, space-time, spatial latitude, texture map, trajectory. So this is the full list, and now I will say something about the audio source, where we say that the audio source type is of diffused type, directional, or the source has a specific shape and a specific size. And here is how all the things are described. Then we have the light source, pretty similar. We have here point light, or directional, or spotlight, or an area. In the case of spotlight, we have these three parameters, but we also have the blend parameter that represent the fallout rate of the light at the border of the basis of the cone of the spotlight. Color information, intensity, annotation, and the same thing. Finally, object audio characteristic, we have reflectivity, the early reflectivity rate reflection measured in seconds, reverberation, RT60, RT30, RT20, and EDT. Then we have diffusion and absorption. Then these are the rights to change the object audio characteristic. Again, this is interesting for the metaverse. Texture map. So we have specified a number of types of texture maps that are possible. And finally, this is the concluding slides. Object and scene descriptor is a big standard. I introduced a very small part of it. It plays a fundamental role in MPAI because it provides the space-time technologies to OSD itself, but also to other MPAI application standard, connected autonomous vehicle, context-based audio enhancement, human and machine communication, multimodal conversation, MPAI metaverse model, and XR venue. And we think that OSD should continue playing this role. Of course, the basis of OSD is now quite consistent, but there are also some needs that are added. Therefore, let me say that we look forward to working with you on this exciting MPAI project. And with that, I will close this presentation. If there is any question, we will discontinue the recording. Any question?